Hello everyone, welcome to Decoding Your Coding YouTube channel. Today we are going to learn one more important DSA concept along with one of the most asked questions by FAANG interviewers. The problem's name states as next greater element in an array, right? Let's understand what the problem says here and as a candidate how we need to approach this problem so that without getting kicked by a FAANG interviewer we will get into a FAANG company. So let's understand what is our input. So we will be given a input integer array where we will have some random numbers. Now the problem asks we need to return an array list or a array whatever the interviewer is expecting. So in this case we need to return a array list. So here, so when it says the next greater element, so for the current element 1, what is the next greater element, which is 3. So that is why at 0th index we need to give as 3. And for the 3, what is the next greater element? The next element is 2, but it is not greater than 3. We need to move ahead again. 4 is greater than 3, so 4 will be the next greater element for 3. So again at the index 1 we have to write 4 as our answer. And again when we move to the index 2, we can see the next element which is 4, which is greater than 2. That's why we have to write here 4. And for 4, unfortunately there are no other elements ahead of the array because the 4 stands at the end of the array. So that's why we will be writing -1. So this is our next greater element problem. So let's move to the whiteboard and decode how we can solve this problem in different approaches and how to build a problem solving mindset to solve this kind of problem and approach these kinds of problems. So yeah, this is the input array that we have just seen, and the output that we need to get is this, which is our answer, right? So here for 1 we need to get the corresponding the next element which is greater than 1 is 3, and again for 3 it is 4, for 2 it is 4, and 4 there is nothing, then it is -1. So what is the naive approach to solve this, right? Like if you want to get kicked out of FAANG interview, naive approach to solve this is again which involves O of n square complexity. You take the element, you start the loop at this element and check what is the next greater element in the rest of the array. That way you will be able to find the 3 and then you update your answer array. Similarly, you do the same process for all the elements. This approach might work when the problem statement and the company is not FAANG, right? Like they will be like, yeah, it's okay, we can take this approach. But now we want to get into FAANG and it is a FAANG level question. So we cannot solve it with O of n square solution. So what is the solution here? Let's try to understand what problem is asking, right? So there are multiple test cases given. If you see, right, so there is a decreasing array here. For example, this particular case, there is a decreasing array. That means for 5 there is no greater element ahead. For 4 there is no greater element ahead. So that means for all the indexes we will have to write -1 as our answer, and we have to return this particular array as our answer, right? So here again, if you see the different examples how they are able to calculate the next element. So the question here is, without approaching with a O of n square solution, can we do it with O of n solution? And is there a way to use any data structure that helps us? So whenever you hear a name or the problem statement saying next greater element, next smaller element, or there is some order involved, then we can definitely make use of stack data structure. So let's move to the stack data structure that will help us to solve this particular problem. So let's keep the answer aside. Let's for now we will erase our answer, right? we'll see how the stack data structure help us to add this particular answer. So first, so what we'll do, so we need to find the greater element. So let's say for one, I want to identify what is the greater element. So in the using stack data structure or whatever the data structure it is, if I don't look ahead of one, I won't be able to find what is the greater element which is greater than 1, right? And this cannot be done in O of n time if we start from here. But what if we start from behind of the array? So I start from 4. If the stack is empty, that means there is no greater element in the stack for this particular element. So what I will do, I will add a -1 at the end of the array, right? So that is one way of doing it. Then we need to find for 2. So we saw that for the 4 element 4 there is no greater element. So what we will do, we will add that element here. 4 will be added in the stack. Now stack top is pointing at this particular 4. Now let's say we move on to 2. And when we move on to 2, we compare if there is any element, that is the top element is greater than the element, the current element that we are at here, right? The I is here now. So we need to check if this particular 2 element is greater than 4. And in our case, yes, it is right. Then our answer will become 4. So we will add 4 here and we will again move ahead. We want to find, then 2 is there, then we will add 2 into stack top. Now I will be moving to 3, that is index 1. So we'll check, is stack top greater than 3? No. So what we need to do is we need to remove until this condition is false. That is, until we find a greater element, we will remove it from the stack. So what we will do here, we will remove the element 2 from the stack. Then the top will become 4 and we check, is 4 greater than 3? Yes, it is greater than 3. So we found our answer, that is the 3's next greater element is 4. So we'll write 4 here, right? Then we'll move on to the next index, but before moving that we need to add the 3 into the stack top. So we'll push the 3 element 3 into the stack top. Now what will happen, I will be moved to first element, that is index 0, and we check the top element of the stack is greater than the element 1, and it is true, 1 is smaller than 3, or we can see the top element, that is 3, is greater than 1. So for the at 0th index the answer will be 3. So now we have completed our looping and we will come out of the loop. I will be moved to -1 and the for loop will be ended, and we have got our answer which we intended to get. So now we'll return the answer. We don't care about the stack because it is use and throw. We have used the stack to compute our answer. Once we found our answer, we will return this answer. Now let's move to the Geeks for Geeks and try to solve this problem in a similar approach. So first I'll take the size, that is array dot length, right? Then when we move to the next particular part, what we need a stack. So I create a stack of integers. I call it stack. Now we need an answer array which will be of size n. Once we get this particular all our required data structures and the answer in place, now we will start looping from the end of the, so we'll start looping from the end of the array. So I will be at n minus 1, which is 4 minus 1 3. Same thing, whatever I have shown on to the board, same thing I will write here. So for will start from uh, the last element, which is n minus 1, and then I should be greater than or equal to 0, that is the last element, then I minus minus, right? So now the first thing what we were checking on the board here, we need to be very careful. So first we need to check uh, the removing part, right? How do we remove the elements? When do we remove? If the incoming element is greater than the existing elements, we remove the items from the stack. So the incoming element is nums of or array of I, right? So what we will do, so we have to remove all those elements. Let's say there are 10 elements in the stack and which are not fitting our condition, we have to remove all those elements. So that's why we use while here. So first, the element that is incoming, if it is greater than or equal to the stack top element we can access with peek function, and if this is the case, I will pop the stack top element, right? Now what error can happen here, right? We are not checking if stack is empty. If stack is empty, then we cannot pop or peek the elements top element. So that's why we do need to add a condition here. If the stack is not empty, then only we'll perform this operation, right? If stack is not empty and if the incoming element, that is array of I, is greater than or equal to the peak element, we'll keep on removing or popping elements from the stack. Now there are two scenarios here now. So once we pop the elements, so there could be a chance that the stack is empty. If stack is empty, then there is no greater element for that particular incoming element. So what we can do is, if stack is empty, so I want to find out next greater element. So let's say I say next greater element for that particular element. So I check stack is empty. If stack is empty, there is no next greater element. That's why I'll be like the next greater element will be minus 1. Or if stack is not empty, if the stack is not empty, let's say stack is not empty, we removed all these elements and stack is not empty, then 4 will become, which is stack top element, will become the next greater element for that particular incoming element. So how do we get that element? Stack dot peak. So here we need to make sure we are not popping the elements out, right? We shouldn't be popping the elements out of this particular uh, stack. We just need to get that element. And once we get the element, the incoming element, let's say the 3 is incoming, that needs to be added into the stack. So that adding part we have not done yet. So that will do stack dot push array of I. So this NGE is the next greater element which needs to be added into a array list. So now this NGE is our answer. We'll add this into our answer array. So this needs to be added at the end. So I will add at the 0th position every time. NGE, right? So this way I will be adding in a reverse fashion. So now I will return my answer. Let's see. Yeah, did work. Submit. Okay, problem solved successfully. We had taken one attempt of, we got 4 scores, and yeah, this is what they have given, what, 20 minutes time to solve this problem, and we were able to solve it in 3.44 minutes. So this is how the FAANG questions will trick you, and you need to understand the core concepts and how do we need to solve those problems. Now let's take a variation of this same problem and see how this can be solved. So there is one homework question that I am giving, which is a 496 next greater element 1 lead code question. Here instead of giving one particular array, they have given two particular arrays. So you need to apply the next greater element logic to this particular array and then find out the next greater elements for these particular elements. The one hint I would like to give here is you have to use two different data structures, and the one is obvious, that is stack, and the second one you figure out. So there is a slight variation of this particular problem, and which was asked in lots of product based companies like Amazon, Microsoft, Adobe, PayU, Zoho, and other most famous companies which are paying handsomely to SD1, 2, and 3 developers. So now let's look at that particular variation, what it is saying. So here it is a medium level problem in lead code, and the problem number is 503. Here again the same thing, we need to find the next greater number, but the given array can be wrappable. So what does that mean, right? So here the problem statement says, given a circular integer array, the next element of this, the next element of last element is the first element. So this is just the same problem with a little bit of trick. Then we'll see how we can solve this problem. Let's move to the whiteboard again. Next greater element 2. They just gave a second episode. It will never be a Dhurandhar 2, but yeah. So let's see how do we need to solve this problem. We know stack will get used for sure, but what are they saying? For 3, there can be other greater elements here. So for 3, what is the next greater element? In a usual case, for 3, the next greater element would be -1. But in this case, for 3, if we wrap around the array, the next greater element is 4. And for 4, the next greater element, if we see, if we wrap around also, there is no greater element. So for this 4, it will be -1. For this 3, the next greater element will be 4. And for 2, the next greater element will be 3. And for 1, the next greater element will be 2. So if we write down the answer, for 3, the next greater element is 4. And for 4, next greater element is -1. For 3, the next greater element is 4. For 2, the next greater element is 3. And for 1, the next greater element is 2. So now let's see, they are saying the array is wrappable. So I will give a small trick. Whenever the array is wrappable, we can use this particular trick to make sure that we are able to solve this particular question. So when they say array is wrappable, isn't this the same question? So here, if you just add one comma, isn't this the same question again? So this array is wrappable. Now, if the given array is like this, you wrap it, you double the array, make the size of the input array twice, and copy the elements as it is in that array. For 3, the next greater element is 4 here. From here, you don't need to go back, you go front and you can get the 4. And for 4, you will get 3. For 3, you will get 4. For 2, you'll get 3. For 1, you'll get 2. So now in with this approach, you don't have to go back and do those complex calculations. So here the idea is very simple. So you double the array will become like this, and from again you keep your index at I, which is equal to 2n minus 1, right? Yeah, so I will become 2n minus 1, which is n is equal to 5. 2 into 5, 10 minus 1, 9. So the ninth index I will be here. So now let's see how do we solve the problem. There's no change in the algorithm. There's no change in anything. We'll just keep doing what we have done earlier. So we will have an answer array and we'll start filling the elements into this array, right? So now for 3, we'll check the array. Array is empty, then we'll keep -1. Here, the point to note here is the answer array will also be doubled, but when we return, we'll return only the first n elements, that is first 5 elements from the answer. So we don't care about the next 5 elements, right? So now 3 will be added to the stack. Now I will be moved to the next index and we'll check the incoming element, which is 4, is greater than or equal to the stack top. It is greater than the 3 element, so we'll keep on removing the elements until this condition satisfies or the stack is empty. So we'll remove 3 from here and stack will be empty. Because stack is empty, we will again add a -1 here. Now 3 will be, sorry, the 4 will be added into the stack top, correct. Now I will again move to 3 and will check if there is any element that is greater than, or the peak element, the stack's peak element is greater than 3. Yes, then we'll add 4 here and we will move this 3 into the stack top. Then again index will be moved to I, and here we'll see 3, which is stack top, is greater than 2. Then we'll have 3 here and 2 will be moved to the stack top. Then again we have 1, which is, and we check the stack top. If the stack top is greater than the incoming element, that is 1, yes it is, then we'll add 2 here and 1 will be moved to the stack top. Now the real question comes here. When 3 comes, we see 3, the incoming element, which is greater than the existing stack top elements. We need to remove all the elements which satisfy the condition where incoming element is greater than or equal to the stack top. So 3 is greater than 1, so 1 will be removed. 3 is greater than 2, it will be removed. 3 is equal to 3, it will be removed. So now once we do this, we see stack is still not empty. So for this, the stack peak element will be the answer. So that will be 4, right? So this is why we added this duplicate element. So for 3, in a usual way, we would have gotten -1. But in this case, we got 4 because we had done already the calculations. So now when we move to the next element, that is 4, before that, when we are at 3, 3 will be moved into the stack, correct. Then we'll move to the 4 and 4 is greater than 3, so 3 will be removed and 4 is equal to 4, 4 will be removed. Now stack is empty. Because stack is empty, we will have -1. Now when we go to the next index and we include this 4 into the stack top, and the index is moved to 3, and we check if 3 is less than, like, is there the top element is greater than 3, yes it is, then we'll add 4 here and then the 3 will be moved to the stack top. Then again the index will move to the 2 and we check the stack top is again greater than 2, then we'll have the answer here 3. And what we can do here, 2 will be moved into the stack top, that is 2, and here the index will be moved to 1. We check 1 is, yeah, 1 is smaller than 2 and the stack top is greater, so for 1 the answer will be 2. So this is the final array we got. We don't have to return the whole thing. We'll take the first 5 elements, that is this particular part. So till here, that is our answer, and we need to return this array. And this particular part is irrelevant. So what we can do is we can take the same length of the array, that is 5, and override these elements, which I will show you in the code. Hope I am able to make justice to this problem and you guys able to learn how to solve this particular problem. Now let's move to the lead code board and see how this can be solved in how many seconds, right? So now as I said before, because it is wrapping around, we need to create a doubled array. Let's say I create an array of nums2, which is doubled. A, it's a new int array, and the size will be nums dot length into 2. This is the array, and let's take I take the answer array with same length, that is nums dot length, right? Now we have to iterate over all the elements which are duplicated in this particular array, but before that we need to duplicate the elements. So what I can do is, the simple trick here is use modulo to duplicate the elements, and just for the simplicity I'll write the length here, that will be n into 2, then I plus plus. Here nums2 will have nums of I, but it will be modulo of n, right? Just format it. Yeah. So this way I'm copying all the elements into one more array which is doubled of the original array. Now when we move to the next stage, that is where our index will start from end of the new array. That is for and I is equal to 2 into n minus 1. I should be greater than or equal to 0, then I minus minus. Once you do this, first thing we need to check is if the incoming element, which is nums2 of I, is greater than or equal to the stack top, it is stack dot peak. And before this we need to make sure the stack is not empty, is empty, not empty, and we need to have a stack. So let's declare a stack which will get used here. So if this is the case, we will remove the top element, or we will pop this top element from the stack. If that is not the case, we need to find our answer and put that answer in our answer array. So answer we can add using modulo I modulo en, because we don't need the second part, right? We just need the first part. So we'll put I modulo en and we'll check if the stack is empty. The stack is empty, then the answer will be -1, else it will be at the stack peak. So once this is done, we have to make sure whatever the incoming element that we are getting, that is moved or pushed into the stack. So we will push the element that is nums2 of I. Once this is done, you just return the answer. Let's compile and see what is happening. Okay, it passed. Then submit it. Yeah, we did well. The runtime is 17 and we are able to solve this problem in one go. Less than 2-3 minutes we were able to solve this medium level, a most famous FAANG interview question. So subscribe, enjoy, happy coding, and whenever you think of solving complex problems in simple manner, please remember Abhay and Decoding Coding channel. Thank you. See you soon.